leads out. We'll solder that baby up. Running out of solder again, I guess. Okay, here we go. I'll throw that away. Cut these two long leads off. Okay, what's next? Oh, we got this P1 right here. We got this P1. Doesn't make any difference which way you solder it. Goes down against the board. Spread the leads. Okay, what else is in there? Not much. Okay, we're getting down to the nitty-gritty. All right, we'll solder that. Get me another batch of solder. That's up against the board right here. Okay. Cut those leads off. Now, there's a couple of connectors on here that you don't have to do right now. One of them is a 3-pin right here for downloading a new program into the microprocessor. If you're not going to be doing that, you don't need to do that right now. You can do that at home. The other one, there's the leftover of this guy. You can cut it into two more 2-pin jobbers. There's 1, 2. One of them goes right here. And this is a way of, if you need it for something external. When you push this switch right here, it activates the 9 volts into the voltage regulator, which creates 5 to run all this stuff. So if you push this down, this connector right here will have 5 volts and ground. When you release it, it doesn't have anything. So it's a way of powering something else up off the board in case you want 5 volts and ground to test something. We don't need that right now, so I'm going to bypass that too. Likewise, over here there's a 2-pin connector. The battery, the 9-volt battery, comes in over here in these 2 pins, and this is a way of getting 9 volts and ground to something else. If you want to try, you got a 9-volt battery, and if you want to power something else, you can make a little cable, stick it on there, and you could apply 9 volts somewhere. We won't put those on right now. I'm trying to save some time here because we're going to be. So you got a connector. You got a 3-pin connector for the download, and you got 2 2-pins for those little external power supply things. We got these 2 chips that we're going to put in the sockets, and we've got the 2 crystals, and we've got the big connector. So that's really all there is to it. So I'm going to put the big connector in because this thing doesn't work without it. And we get that in there. And I'm going to have to do the same thing. I'm going to pull these things off. And I'm going to use my roll of solder and a nice big bent over lead because I got to hold this thing in. And I'll do 1 pin at the top. Okay. And 1 pin at the bottom. helps if it actually comes up around and goes down, so you can get it around stuff. So okay, there it is. So now that I've got this thing so it won't fall out, I can go back up and give that one a nice resolder. Wait for it to cool, although I am holding it with my finger, and reseat that one because it was kind of a hokey solder job when you're doing that third hand business. I'll put this thing back on just so it's nice and level again. Oops. So now I can go and go right down this row of pins. So here's okay, so there's 13 pins down there, and what I'm going to try doing is getting these out of the way, yet still just barely hanging onto the board over here. I'll come around this corner. There, now I can get in this side with my iron. Clean it up. Put a nice tin on it. Okay, that's soldered. Let me take this off. Now, again, those are standing proud. They're tall, so I'm going to cut them all off. And the reason is because when we drop this down to an Altoids tin, we're going to need all the height we can get for that 9-volt battery to be able to clear the tin without interfering with the cover being closed. So this board has got to sit as low as possible, which is another reason why it's an 031 thick board. It's not a normal size board. It's half the thickness of a regular board to add a little bit extra room. Oh. Okay, so switches, all that's done, that's done, that's done. We don't have the 5 volts in ground, we don't have the 9 volts in ground, but that's okay. Everything else is done. We can put the crystals back in. Okay, we'll put a jumper on either one, but not both. You only got one jumper, so that's all you can do. Okay, we got got a microprocessor that I've programmed already. So we'll put that, it's oriented the right way. Set that in the socket. You got to make sure these pins are at 90 degrees and not spread out. And find the right end. And there she is. She's all built. All we got to do is I'm going to have one thing left over. We have to build a test cable. So I'm going to take a 2-pin connector, and part of the kit, where'd it go? Part of the kit is 2 alligator clips. Oh, there they are, right here. Right behind my trash bin. So we will tin these guys. Okay. I think what I'm going to do is let's see if I can't use this to just sort of okay, we'll go back to my patented pliers and rubber band technique. We'll bring out the trash can. We'll grab this, open the pliers up, lay them on there, and get my solder. And tin it. Okay. We'll get the red one. Tin that one. Okay. And so what we'll do now is we will that's a little blobby, I think. Let's see if that's going to fit in here. Okay, so I got that. I got it all the way out, and yeah, okay, that will work. And so what we're going to do is I'm going to take one of these 2 pinners. Rats. I can't hold on to that. That's too hot. And now fortunately, I have a second pair of pliers. Remember I said those are my favorite pliers. I got about eight of them floating around, so I'll take my second pair of pliers. Do the same thing. Now I can hold on to both of these pins. Okay. See, I got it going across the long side of those pins, and I'm going to hold it this way, and I'm going to go underneath that pin. or on top of it. I'll go underneath it and, well, first I guess I better tin those two pins very carefully. Just a little bit of solder. We don't want to blob them up, and we don't want them okay. So they're tin, so I'm going to go underneath that guy. Come down vertically and solder those two together. Okay. On the outside, I'm trying to keep the distance between the two pins clear. Okay, I probably should have actually put the other lead in there too. So now I'll do the same thing with the red one. See if I can get it to come out the other hole. There it is. Okay. So, and I want that. Oh, that is on the bottom. Okay. So, I will hit this guy. Okay. And I'm looking at my solder job. It's not too bad. That second one was a little bit on the blobby side, so I'm gonna flow it up to that pin. Okay. I think that's all right. There you go. Now I can probably, I'll take one of these things off now. I can just try to shove it back a little bit, but I don't think it's going to go very far. But that's okay, because what I'm going to do now is I'll take, well, it's got to heat up first. I'm going to take a hot glue gun, and I'll hot glue around that so that it's covered, and nothing exposed, and it's got strain relief, and it's sort of all one piece. Or I could do that and then put a little piece of heat shrink around it. But the idea now is this thing plugs into any of these two pins. Okay, and those are the various test things that we can do, use this PocketPAL for, and you can select any one of those tests, and now you got a pair of test leads to be able to do that with. And the positive side is over here on the inside, and these are all ground. So you would have the red, black at any one thing. So if you want to test a crystal, for instance, you put it in the crystal thing, attach these leads to a crystal, power this up, and it will measure the crystal frequency. And if it's the crystal actually runs, it'll tell you what the frequency is. The only thing we got left is the 9-volt battery cable, which is right here. Now in this case, we don't need a ton of battery. I'm going to cut that lead off. The battery's going to go this way, I think, because the other way it's kind of short. So I like to have a little bit of lead so you can pull the battery out and hold on to this while you're doing something. So I'm going to do right about like that. So I'll cut these off. Did that? Boy, they don't make these things very sturdy anymore. It's just barely enough wire to make a connection these days. Used to be a 9-volt battery snap was a nice solid snap. So I'll tin these. And this will go in the plus side of the 9-volt. I'm going to bring my solder out. I'm holding this I'm holding this lead in, pushing it right up to the edge. Oh, that's pretty nasty. That's still pretty nasty. Oh, that's better. Yep, okay. There's a good connection. So I can put the other one in. Put a little solder on there. And I think that's it. Well, I think it needs a little bit more solder. Yep, okay, I like that. Cut those off. Okay, so there is the PocketPAL. So this will go up and go to the battery such and such. So this guy here, when you push this switch down, activates all these tests all the way up to the frequency out, the F out. And we'll go through that sequence. I'm going to do a video about testing things with this thing. There is a print version of how to test things on the web page, but I'm going to do also do a video. That's next. This one here, when you push this button, it actually grounds this circuit over here. This circuit's getting 9 volts all the time, but there's no ground. This will supply the ground to here. So what happens is this FET oscillator now will oscillate based on whatever crystal has been activated. So right now it'll oscillate at 3.560, and that comes down here and goes to F out. So you could actually attach your lead to F out and end up injecting your crystal frequency into something else. Like if you're testing let's say you want to test a frequency counter that somebody's trying to sell you for 20 bucks. Well, now you've got 2 different frequencies you can test it on. Or if you've got a receiver, you can take, let's say we want to test out 80 meters, you activate your 3560, and you turn it on, and you got your test lead coming out, so you got a very small transmit antenna. You can go over and have this by the receiver, and you go over and you can tune in and see if you can hear the crystal. And of course you can turn it on and off, so you can actually key it. Anyway, we'll go through all that when it's done. The only other thing you have to do is you have to find a piece of nice, good, thin cardboard. A thin cardboard, but something that's resilient. I like to use, a heavy cardstock, and you trace this board out and cut the cardboard out so that you can drop that into the tin, and when you drop this in, that now isolates all these connections from all these solder joints from shorting out on the bottom of the tin. So you've got to do that, and we'll go into that on the next video. Now that we've built it, we're going to use it, and that's all I got for tonight. So I'm going to turn this one off and go do another one. Thank you. Enjoy.